Test 13, review B for your quarterfinal tomorrow. All right, question number 1 says, and hopefully I'm recording, I don't remember. Sometimes I blank out here. Yeah, we're recording. Okay, let's see, at this point, my turn. Use the midpoint formula method to find the equation of the perpendicular bisector line segment whose endpoints are 3, -2, and 5, 4. Write the equation in general form. That's the only part of it that I won't be expecting you to do is the general form of the equation. I'll be expecting your answer in y equals mx plus b. So going over to this, let's see, we'll pull this up. You'll start off with the midpoint formula, and then we will also want to use the slope formula. So we'll find the perpendicular slope, so we'll need the opposite reciprocal of what we find there. Then we'll plug everything into the y minus y1 equals m times x minus x1, if that makes sense. All right, so because we have 3, -2, and 5, 4, what I started off here is 4 plus 2 divided by 2. And let's see, and then we had 3 plus 5 divided by 2. Okay, 4 plus 2 is 6 divided by 2 is 3. And 3 plus 5 is 8 divided by 2 is 4. So that's going to be the xy coordinate that's going to go into our final equation. Our y minus y1, let's see, and I ended up doing this a little bit differently, I guess, but we can do 4 minus -2, okay, which over 5 minus 3. Did I do something wrong? For your midpoint? Yeah. Oh, did I do something wrong? You got what?
4, 1.
What did I do wrong here?
It's supposed to be -2.
Oh, okay. All right, so 4 plus -2 is 2. 2 divided by 2 is 1. And this is what the y's. And then 3 plus 5 is 8 divided by 2 is 4. So you got 4, 1. All right. I'm sorry. Okay. All right. 6, let's see, what is this? 6 halves, which gives you 3, which means we're going to use -1/3. Okay, so in our equation, we're coming down here, y minus 1 equals, let's see, we got -1/3. I could draw that a little bit better. Let's see, equals -1/3 times x minus 4. Okay, y minus 1 equals -1/3 x. Let's see, and that's going to be what? Positive 4/3. Right, and then we're going to add 1 to that, which is going to be 3/3. So we should get y equals -1/3 x. Let's see, plus 7/3. All right, that's what we want out of that. All right, did you guys wind up with that, though? Okay, great. All right. Well, let's see. Let me erase this. If it works. If it doesn't work, there we go. All right, let's get back over here. Question number 2. The accountant was disappointed he knew that D dollars would finance J bands for 7 days. At the festival, but he had to pay J plus 3 bands. How many days would N dollars last? Okay, we'll come back over here. So rate times workers times time equals jobs. You're going to start off with rate. Your workers is your band members. So J, you got 7 days here and D dollars, correct? All right, so your R is going to be equal to D over 7J. So we're going to use D over 7J down here. And then they said what? We ended up with like 3 more in the band than what we started with. So we have J plus 3. And there's no difference between the J's. I'm just, whatever. Sometimes I draw it capital. Sometimes I do it lowercase. Okay. All right, and then we're going to be solving for time. And we want to know what N dollars is going to do, right? All right, so the first thing I'm going to do is I'm going to distribute the J plus 3 to the D, or the D to the J plus 3. And a lot of times we'll just end up leaving that out because it's going to factor out the other way whenever we do that. So 7j times t equals n. And so that would mean that I'm going to divide by a fraction, which I can't do, so I'm going to multiply by the reciprocal. So you wind up with 7 over, or n over 1 times 7j over d times j plus 3, which is going to leave you with 7jn over, and you can distribute it, you can leave it out. Either way, I'm going to take it, but I'm going to leave it as factored out as d times j plus 3, and we're dealing in a matter of days. Okay, so that's our answer right there. Did we get that? Great. All right, rather than try and do erase, because it doesn't like to erase, we're just going to move to a different page and go to number 3. Find the equation of a line that's equidistant from the points 5, negative 3, 3, 2. Use the locus definition method. Write the equation in slope-intercept form. Are any of you still using the perpendicular bisector method? That basically what you'd use from question number 1, right? I'm curious to know what you got when you did that and you put it in this slope-intercept form. What did you get? That's your answer. Yeah, you definitely want to have your review out to look and check this stuff. Anybody else do it, or just Miles? No, everybody else did it the square root distance formula way. Do you have an answer for 3?
Yeah.
Okay. Well, I'm going to move over to this page. Let me know what you got when you got it. Anything yet? Well, if you don't have your review, I can't give you credit for it. Okay, so we're going to drop off our square root symbols and we're going to FOIL what we have inside. So x minus 5 squared is going to be x squared minus 10x plus 25. Okay, plus y squared plus 6y plus 9 equals x squared minus 6x plus 9 plus y squared, let's see, minus 4y plus 4. Okay, work out so far. All right, we can always factor out our squares because you're going to get the same thing on both sides. You end up finding your stuff yet? Okay, better keep looking. Okay, all right, so we want to set this up so I have y on one side, everything else on the other side. So I can add 10x, and I want to, looks like subtract 34 over to the other side. So we're going to add 10x, and we're going to subtract 34. We want to move all our y's from the right-hand side to the left-hand side, so we want to add 4y. Okay, there. Okay, we should be able to come down. Looks like my y's are 10y. Okay, I don't have any other y's to work with. Next part of it is the x's. Negative 6x plus 10x is 4x. And I've got a couple of things. I've got 2 different constants to work with there. So I'm actually at 13 minus 34. Okay, which brings me to what looks like negative 21. Okay, divide by 10 on both sides. I'm going to get y equals 2/5 x minus 21 over 10 for my answer. Okay, did we get that answer? You found it? Was this the answer that you got? Okay, so if that's the answer you get doing perpendicular bisector, then that works. And I'm more concerned with being able to get the right answer, but this is the method that they use. Okay, so if when you see equidistant you think this instead of perpendicular bisector, then I would do this, right? Whatever's going to help you get it right. Okay. Okay. All right, number 4. Out of curiosity, what did you guys get for an answer?
64 days.
64 days. Anybody else? Okay. What'd you get though? Okay, keep that paper out. Okay, I don't want you to lose it again. Okay. All right. Well, let's take a look then. All right. Let's see. Number 4. Let me go back here. Number 4. Hadrian could do 5 jobs in 8 days. Leif could do 1 job in 2 days. Leif works for 4 days, and then Hadrian begins to help. How many days will it take them working together to do 74 jobs? Okay, so we're going to start off with our first guy, and what does it say? He can do how many jobs in how much time? 5 jobs in 8 days, so that's his rate. Okay, the other guy can do what? 1 job in 2 days? 1 job in 2 days. Okay, now the second guy, he's the guy who starts working early, right? So he starts working 4 days early, right? Is that right? Okay, so we have 5/8 t plus 1/2 t plus 4, and they're trying to get some jobs done. In fact, they're trying to get 74 jobs done. So we're going to distribute this t, so we're going to get 5/8 t plus 1/2. You could call it 5t over 8, and then 1/2 t, that's fine. But then we're going to take the 1/2 times 4, which is positive 2, equals 74. We're going to combine 5/8 t and 1/2 t to get one fraction. Let's see, 5/8 t plus 1/2. Well, that would be the same as 4/8, so I should get what, 9/8 t? So we got 9/8 t. We're going to subtract 2 equals 72. We're going to take 72 times 8/9. Okay, so t equals, let's see, it looks like 576 divided by 9. Okay. Okay, which equals 64 days. Okay, 64 days. Does that clear things up for you a little bit? Okay. All right. Number 5, write the quadratic equation with a lead coefficient of 1, whose roots are 1 plus 2i and 1 minus 2i. 1 plus 2i, 1 minus 2i. 1 plus 2i, 1 minus 2i. What's our method here? Sum product. Okay? So if I add these up, the 2i and the negative 2i cancel out, correct? Leaving me with 2. But as I bring it down, what do I have? Negative 2, right? Negative 2x. So I'm going to start off with x squared, and then I'm going to get negative 2x. All right? Now for the product. 1 plus 2i, 1 minus 2i. Okay, 1 times 1 is 1. All right? Then I just need to do the 2i's because it's a sum difference. So 2i times negative 2i is negative 4i squared, which is positive 4, which is 5. Positive 5 equals 0. So x squared minus 2x plus 5 equals 0. Okay. They put the equals 0. You should put the equals 0. Am I going to probably count it wrong? Probably not. But put the equals 0 on there, okay? It did not sound very optimistic. I like to leave my options open. Okay. All right, let's look at our next one. Okay, let's see. 6. Bullet train went X kilometers in T hours, but arrived 1 hour late, so we're dealing with the distance, rate, and time, correct? Okay. How fast should the train have traveled to arrive on time? Okay. So distance, rate, time. Okay, his distance was X, right? His time was, he was an hour late, right? His rate was X over T plus 1. Correct? That was the rate it was at which he was going. We want to know how fast he should have been going to have arrived on time. So we're dealing with new rate, right, equals new distance, which isn't changing, but I am going to put it as x over 1 because we're probably going to multiply by a simplified denominator. All right, and it should be over x over t minus 1. Is that correct? Hopefully I'm getting that right. Oh, hold on a second. Oh, it it's just, I'm sorry, it's just a matter of correcting the rate. So it's the same rate over our new, well, it's just a new rate, so it's just x over t minus 1. I'm sorry. I made that way more complicated than it really needed to be. Okay, x over t minus 1. Okay. All right, let's see, number 7. Given the function, the absolute value of x, write the equation of the function whose graph is the graph of f translated 2 units to the right and 3 units down. Sketch the graph of the new function. Okay, so what you should get here, what they're saying is, what is g of x? And we wanted what? How many units to the right? 2. So it's going to be x minus 2, correct? And then where did I want to go, up or down? 3 units down. So it should look like this. So, let's see. The absolute value of x graph is going to look like this. So we're going to take that vertex, we're going to move it 2 to the right, 1, 2, and 3 down, 1, 2, 3. Okay, we're going to put that there. Should look like that. Should look like your green line. Okay. Absolute value functions always look like these. Okay. Are we doing pretty good with these so far? Okay, let's see, what are we ready for? 8. Try to get as much done as I can. Solve the following equations of 0, we're in that range. We want sine theta equals negative radical 3 over 2. And we have tangent theta minus radical 3 equals 0. Okay, I think we can do both of these right here. All right. Let's see, somebody give me that first one again. What was that? Okay, so this is just a simple matter of opposite, which is at negative 3. So if it's at negative 3, I'm in the 3rd and 4th quadrant, right? So I'm down here, negative radical 3, or I'm sorry, negative radical 3, negative radical 3, hypotenuse of 2, hypotenuse of 2, 1, negative 1. This should be 60 degrees, right? Correct? All right, so what we're actually looking for, though, is the number of degrees at which that shows up. This shows up 60 degrees past 180, which is 240. And this shows up 60 degrees from 360, which is 300. So your answer to that, because we've got to fit in there and I can't go around again, is 240 and 300. Okay? So this is the answer to A. All right? What was, let's see, let's put A. What was B? Okay, tangent theta over 2, right? Minus radical 3 equals 0. So first thing you want to do is move the radical 3 over, right? So we got tangent theta over 2 equals radical 3, and I can write that off as radical 3 over 1. Okay, which this actually works out pretty nice because we're saying that opposite, right, which in this case is kind of like, because it's sine over cosine. Somebody at the door? Oh, somebody was pointing. Well, yeah, it's going to be up, right, with a positive 1. Okay, we're going to get a radical 3 here. We're going to get a 1 there. But is that the only place where it can show up? Okay. Let's see. Yeah, I would think that we could get here too. Negative radical 3, negative. Right. Yep, that's the reason it doesn't work. Okay, so this is 60, correct? 60 degrees. So we're getting theta over 2 equals 60, but we have to multiply by 2, so we get 120 degrees. The other one comes out to 240, right? But we'd have to multiply by 2 and get 480, which doesn't work. So it's just 120 degrees. Okay? So A and B. We're good there? Great. Let's see. Number 9, find the equation of the following sinusoid. Okay. And this is still part of the earlier part, but at this point, the only thing they're changing so far is the center line. Okay. So as we look at this, let's see. We want y equals, and the first thing we want to list is our center line, then our amplitude, okay, then our function. Okay. All right, so what is our center line in this? 13. Okay. Is it sine or cosine? Cosine. Is it positive or negative cosine? Negative. What is the amplitude? I'm going from 13, right, down to what? Down to 11. Or wait. Oh, down to 2? Yeah. So I'm going down from 13 to 2. So how far am I dropping? I'm dropping 11. Okay? And because you said it was a cosine function, I'm going to write cosine. Am I using x or theta? X. That's my answer. Y equals 13 minus 11 cosine x. Okay? Any questions on that? Typically, it's the dotted line, but if you know how to always find a center line, find the minimum and maximum, and find the average of that. So add those up and divide by 2. Okay? All right. Let's see, number 10. Number 10 gives you quite a bit of, let's see, I want to. All right, number 10. Number 10, this is going to come down to a graphing calculator deal. The following data comes in. The first thing that I want to come up with, though, is what is the x and what is the y. I'm going to look in here. So because y equals mx plus b, so this is my y, and this is my x. So we're going to take this data, we're going to plug it into our graphing calculator. Okay, let's turn it on, clear things out, stat. I want to edit our list. So 11.5, 8.2, your x's always go on the left, 8.9, 10.1, and 6.9. Looks like I don't have to worry about having to delete anything. Now for our y's, 33, 24, 30, 29, 16. Okay? From here, we go back and we hit stat again. We come over to calculate, and what we want is linear regression because we're wanting something that's going to give us that y equals mx plus b. They're just substituting a in for m. Okay? So what we should get here, what I get anyway, is we get, and they'll leave it in that formula, so they'll say C equals, looks like 3.44 x minus 4.93. Okay, and they say discuss whether or not the line is a good model for the data. Because my R value is 0.9, right, as opposed to 0.1, right, it's a good line. Even if it was negative 0.9, it would be a good line, right? It would just be in a negative direction. So we're going to say, good line. But I would appreciate it, well, actually, I'm going to ask you to give me the R value, okay, to back this statement up, okay? Okay. All right, so we understand what's going on there. Let's look at 11. If I can figure this out. All right, 11.
But if it's 0.8, it's still a good line, right?
0.8 is still, it's not as good of a line. It should always end up on these questions be very clear, right? It should be 0.9 or 0.1 or in that direct ballpark. Okay, if it was like 0.89, we'd round it up to 0.9, right? Okay. All right, so somebody read this number 11 off for me. We have tangent squared, and then it's in radians, right? Okay, what is it? 4 pi over 3. What's else is after that? What's it minus? SEC? Okay.
Squared. Negative 11 pi over 6.
Is that it?
Yeah.
Okay. All right, so I already have some of this work drawn out, and hopefully that you guys have got it too, but your tangent squared should come out to 240 degrees. Is that right? Is that what you guys got? Minus secant squared and negative 11 pi over 6. Let's see. Yeah, I got negative 330 degrees. Okay, so first order of business is 240. I'm coming around in my positive degree, so I'm at 60, right? Okay, so I'm at radical 3, and because we're looking for tangent, let's see where this is going to be 1. Negative radical 3 over 1. Yep, negative 1. So, yeah, negative radical 3 over negative 1, and we're going to square that. Okay, but we'll wait on that here for a second because we're going to come over here to secant 330. So that's coming around clockwise. We're 30 degrees shy here, so we're at positive 1, positive radical 3, and 2. Right? Secant is reciprocal to cosine, so we want is hypotenuse over adjacent. So we have minus 2 over radical 3 squared. Okay, so let's come back to this first one. That negative radical 3 times negative radical 3 is going to be 3. Okay, negative 1 times negative 1 is 1, so we can just write it off as 3. And we're going to subtract. 2 squared is 4, so we're taking 3 minus 4 thirds. 3 minus 4 thirds should equal, where am I at here, 5 thirds. All right, so that's the answer you should get out of that. Okay? Very good. There's a 3 at the bottom. It's just, for whatever reason, whenever I get to like this area of my board, it doesn't pick it up. So I don't know if I need to just recalibrate or take a baseball bat to it, one or the other. I'll have to explain that to the Doug. I don't know what happened. It just exploded. All right, we want to write 4900 as the power whose base is e. That's natural log of that. So all we're doing here, and I can probably just type this out here, ln 4900, and it's going to give me a decimal, right, which we're going to write off as e, and that decimal should be e.4970. That's your answer. Okay. The ln 4900 is all it's going to do is give you 8.4970. You're going to put that as the exponent to e. Okay? So pretty easy. That's the extent of your work right here. Okay? All right, let's see. We're down to 13. 13 is a graph. It's an exponential decay graph. So it's going to look something like that. You're going to give me a table of values. In this case, I just kept with numbers that showed up really easily, like 0, 4, 1, 2, and 2, 1. Okay, 0, 1, and 2. Okay, can we do that? Okay, great. Let's see, that was 13. I won't have a whole lot to do on the second part of this. 14. We need to write the graph of we need to write the equation of the change, right? So we want to look at this. Notice, if we're here, and this is the square root of negative x. And what we want to do is we want to flip it below the x-axis, but we also need to move it 3 down, 3 to the left. So in doing that, g to the x, in order to flip it below the x-axis, we put a negative out here. Okay, it's already facing the right direction, so we're not flipping it across the y-axis, but I do need to move it 3 to the left. But because I'm inverting it, it's minus 3. Okay, normally minus 3 would move us 3 to the right, but we're inverting it. Okay, and that's why it's, because of this negative out here, it changes that. So we should get g to the x equals negative square root of negative x minus 3. Okay, and you can always check that in your calculator and see, did it wind up where it was supposed to wind up in the direction and everything the way that it looks like on the test, right? And if it doesn't, then you've done something wrong. You can guess and check and try some different things. Okay? All right. What are we ready for? I don't know. We'll try to get through, 15. How many of you in here are planning on doing the proof? Okay? So I'm going to read this out to you. Okay? Just, so you have your given, right? All right, the next thing that you're going to get out of this, rather than me just kind of walking through all of it, is that you're going to get angle IGH is going to be congruent to angle, and my handwriting is a mess here, angle KI, what's that? Yeah, I wrote, okay, yeah. Angle IJH is congruent to angle K, let's see where, KH, or J, KHJ, right? And I'm going to write next to that alternate interior angles are congruent, right? And if I really wanted to be more specific, I would say, parallel, two parallel lines cut by transversal have alternate interior angles congruent. Then I've got my other given listed, and then I've got another set of alternate interior angles congruent. Okay, what that's going to give me is two angles congruent to two angles, so I can write angle angle equals angle angle angle, right? And so I can show angle I is congruent to angle K through that. Then I used HJ is congruent to HJ, meaning it's reflexive, because if I'm going to prove that these two triangles are congruent or these two parts are congruent, then first I'm going to have to prove that the two triangles are congruent. And I do that through angle 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 side congruency postulate. And then I can say that IJ is congruent to HK using CPCTC. The only part I'm in here that I'm seeing is not necessary is angle I congruent to angle K, because we can use angle angle side, right, instead of angle 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 side. So that would save me a step. Okay, does that make sense without me having to, two-column proofs take a long time to write, and I don't want to chew up any more than I have to. All right, so that's the first 15 questions. On my conference period, I'll get you 16, 17, 18, 19, and 20, but they're actually the easiest questions on the review, right? So what I will give you before I go is I will give you my worksheets, and you can do with that what you want. All right, I'm going to hit stop.